friends, welcome back to our channel. So hope all are doing well and safe at home. So don't go outside and stay at home and be safe. Right. So today we are going to discuss about one more concept in operating systems, that is page replacement algorithms. So in that we'll see what are the basic terminologies we are required to know before going to this page replacement algorithms. So the basic terminologies used. The first one is page. So what is meant by a page? Second one is frame. Frame. Third one is swapping. The fourth one is page fault. Fifth one is hit. And the next one is the techniques used. Right? So page, frame, swapping, page fault, hit, and techniques. Now coming to this page replacement algorithm, we know that the processor will load the process which is going to be executed into the main memory from the secondary memory. So we know that all the files and all the processes will be stored in the secondary memory. So whenever we are executing the process or a file, whenever we are loading the file, that file or that process will be loaded into the main memory and then it will be executed. So for execution of the process, it should be loaded from the secondary memory to main memory. That is an important concept. Right. Now the question is it required to load the complete process into the main memory? The answer is no. So here the process will be divided into different parts and each part will be loaded from the secondary memory to the main memory whenever it is required. So that each part of the process is called page. So process will be having pages, page 1, page 2, page n. So there will be page number, right? So a process can be divided into number of pages, n number of pages. Now this is about the page. It's a part of a process. It's a part of a process. So if we want to execute this page 1, first the page 1 should be loaded from the secondary memory to main memory and then only it will be get executed by the processor. Now coming to this frame, similar to the process, the main memory is also finite and the main memory is also divided into different frames. See, main memory so frame 1, frame 2, frame n. Right? Now, if page 1 is to be get executed, that page 1 should be loaded from the secondary memory to main memory in one among these frames, which is available. Right? So this is a frame. Frame is a part of main memory. Swapping. See, this is a main memory. See, this is a frame 1, frame 2, frame 3, frame 4. So memory is divided into 4 frames. Similarly, we are having some process P1, P2, P3, P4. Sorry. You can write here P1, P2, P3, P4, P5, P6, P7. So there are here P1 is nothing but a page 1, page 2, page 3. So this is the process. Right? If you want to execute this process, first we have to load these pages into these frames. So see, we are executing this one. So page 1 is here. next page 2 is here, page 3 is here, page 4 is here. Now the processor want to execute the page 5, right? Now the processor wants to execute page 5. Now this page 5 should be loaded from the secondary memory to main memory. So this is the secondary memory. Okay, this is the process. Right. So we want the processor wants to load this P5, execute this P5. So first the processor will check for the main memory, check for this required page in the main memory. If it is not available, then it will load this required page from the secondary memory to main memory. And before loading that, it will check for the availability of frames in the main memory. If it is available, that directly that required page will be loaded into the available frame. And if the frame is not available, what we have to do? So one page should be replaced with the required page. So in this example, so here there are 4 frames in the main memory and already the 4 pages are filled in this frames. Now the processor wants to execute this P5, page 5. So page 5 should be loaded from the secondary memory to main memory. But here no one frame is available. Not even one frame is not available. So we have to replace one page from the main memory with the required page. That is called the technique. So with the help of, this process is called a swapping. Okay, so here replacing, that means removing the page, from main memory, that is one step. Load page from secondary to main memory. Okay, these are the two things must be happen. So before loading, we have to check for the available frame. So this process is called swap out. So because we are removing, that means we are removing the page, one page among several from the main memory to the secondary memory. So that is called swap out. And immediately the required page will be loaded from the secondary memory to the available frame. So if you remove the page from the main memory, that particular frame will be in an available state. So we can load the required page from the secondary memory to the main memory. So available frame to the available frame. So this is called swap in. So finally the process of switching the pages from secondary memory to main memory is called swapping. So that can be swap in or swap out. Right? Now, so page fault. So page fault means loading the required page from the secondary memory to main memory. If the required page is not available in main memory, then that is called a page fault. So there is a page fault. So we have to load the required page from the secondary memory to main memory. Right? So this is called a page fault. So that means the required page should not be available in the main memory. So that is called a page fault. And if the required page is available in page fault, in main memory, that is called a heap. So the required page is not available in main memory. Hit means the required page is available in main memory. Okay, right? See, for example, now let us consider this example itself. So already all the frames are full, right? See, okay. Let us take an empty frame. So let us start from the beginning. So the page sequence is same, the P1, P2, P3, P4, P5, and similarly again, P1, P2, and P3. The page sequence. The processor wants to execute the process in this way. Okay. So first of the P1, first it will find, the processor will find whether the page 1 is available in the frame. So all frames are empty, it is not available. So that means there is a page fault. So P1 will be here. So there is one page fault till now. Coming to the P2, P2 is also not available in main memory. Second page fault. P3, third page fault. P4, fourth page fault. Again P1. So P1 is already available in main memory. Okay. So we need not swap any page. P1 is already available in this one. So there is no page fault. So there is one hit. Again P2. P2 is also available in main memory. So second hit. P3. P3 is also available in main memory. So third hit. So for executing this one, we are having 4 page faults and 3 hits. Hope you understood. So whether the required page is available in main memory, then we call it as a hit. Whether the required page is not available in the main memory, that is called a page fault. So the next step of this page fault is we have to load the page into the memory. So for that we have to again check for the free slots of a memory, that means the free frames. So if there are no free frames, what we have to do? We have to swap. That means we have to replace one page with the required page. So that swapping will be take care about these page replacement algorithms. So based upon the page replacement algorithms, this swapping will be done. So which page have to be replaced from the main memory and which page, to replace the required page. So the selection of a page to remove from the main memory. So that is called this page replacement algorithms. There are three page replacement algorithms. So first one is first in first out, Fifo page replacement algorithm. First in first out page replacement. LRU, least recently used page replacement, least recently used. And the third one is optimal page replacement algorithm. Optimal page replacement algorithm. So these three are nothing but techniques. Techniques to replace the page from the main memory with the secondary memory, with the required page. Okay, so hope you understood this one. So in order to select which page has to be replaced depends upon the technique which we are using, either Fifo, LRU or optimal. Right? So these are the basic terminology which we have to learn before going to these page replacement algorithms. So page, which is nothing but a part of a process. A frame is a part of a memory. Swapping, that means replacing the pages from secondary memory to main memory. Okay. Then page fault, if the required page is not available in the main memory, then this page fault occurs. And hit, if the required page is available in the main memory, so we have to do nothing. So that is called a hit, one hit. And techniques, so if the memory is full and if the required page is not available in the main memory, then we have to replace one page with the required page. So which page, the selection of page to be removed from the main memory will be done with the help of these techniques, Fifo, LRU and optimal. Right? So hope you understood, guys, this introduction to a page replacement algorithms. So from the next session we will go with the three techniques. So next session we will go with the Fifo and then LRU and then optimal. So in the previous session we have already discussed about the introduction to page replacement algorithms. In that we have already covered a few basic terminologies that we have to know while applying the techniques of page replacement algorithms. So in that we have already seen the page replacement algorithms are three ways, three algorithms. That is a first in first out algorithm, and the least recently used an optimal page replacement algorithm. So in this session we'll go with the first one, that is first in first out. Fifo page replacement algorithm. Right. So if the required page is not available in the main memory, we have to load the required page from the secondary memory to the main memory. And in order to load the required page, first the memory should be having a free frames. So if all the frames are filled with some other pages, so we have to replace the existing page with the required page. For that we will use these page replacement algorithms. So the question is, which page of the main memory should be replaced with the required page? So that depends upon the algorithm. So here in this algorithm we will replace the first page loaded into the main memory with the required page. Right. So we'll go with some page strings, page reference strings. So page reference string 1, 3, 2, 4, 2, 3, 1, 4, 2, 4, 1, 3. I have taken this as random thing. Okay. So here the pages are 1, 2, 3 and 4. So there are 4 pages. So a process is divided into 4 pages. And let us assume that frames are 3. 3 frames. Frame 1, frame 2, frame 3. Now see. Frame 1, frame 2, frame 3. So we know that, so if the required page is not available in the main memory, so here this frames is nothing but our main memory, right? So if the required page, so these are the page reference strings. So if the required page is not available in the main memory, that gives a page fault. And if the required frame or required page is available in the frame, then it is called a hit. Now we will have to find the page faults. The page faults, number of hits and hit ratio. So we have to find all these three. Now let us consider. So now all these frames are empty. All these frames are empty. Consider the first one, page 1. So first we have to, the required page is page 1. The required page is page 1. So we have to check whether the required page is available in the main memory. So here the required page is not available in the main memory because all the frames are in a free. So just I am loading the first page, the required page in frame 1. Right? And the 2 frames are empty. So first, okay. So before loading it, so page, the required page is not available in the main memory. That is, here there is a page fault. The page fault occurs. So first we have to load this in the main memory. Next, 3, page 3. Again, see, in the given frames, 3 is not available. So again there is a page fault. Now the question, we have to load the required page into the frame. So there are 2 slots are free. So we are loading this 3 here. And coming to the third string, second page number 2. So it is also not available in the main memory, and one slot is free. So see, again it is not available in the memory. So we said that if it is not available in the memory, that is a page fault. Page fault. So I am loading these two in frame 3. Now our main memory is full with all the pages, right? So 3 frames are there. So 3 pages has been loaded. Now the next stream is 4. So 4 to be loaded into the main memory. But 4 is not available because frame 1 is having 1, 2 is having 3, 3 is having 2. So not available in the main memory. So again there is a page fault. Okay, again there is a page fault. Now the question is, whenever we got the page fault, we have to load the required page into the main memory. So but here there is no free slot. All the slots are free. All the slots are full, right? So now we have to replace. That means a swap out should be done. Swap out means one page should be removed from the main memory. So which page should be removed? That is first in, first out. Our algorithm gives the first in, first out. So among these 3, which page is loaded first, that should be removed. So by your observation, we can know that 1 is the first page to be loaded among these 3, 1, 3, 2. So 1 will be replaced and 4 will be loaded here. Hope you understood. Again, coming to the next string, 2, page 2. See, page 2 is already available in the frame 3. So there is no page fault. So hope you understood. If the required page is not available in the frame, then the page fault will be there. If the required page is available in the frame, that is nothing but hit. So nothing will be changed. So we need not go with any change because page 2 is already available in our main memory. Okay. Next, stream 3. Next one is 3. Again, the same process is applied. So we can know that 3 is already available in frame 2. So again hit. So no change will be done. Next again 1. See, you can observe 1 is not available in the main memory. So there is a page fault. Page fault. So 1 should be replaced with 1 among these 3. So which to be replaced? Which page to be replaced? So that is first in, first out. Among these 3, 3 is the first. Okay. So 4 is having only 3, 3 is having 5 and 2 is having 4 iterations. So 3 is a first loaded into the main memory among 4, 3 and 2. So replace 3 with 1. So 4, 1 and 2. Next 4. Again the same process. So but 4 is available in the memory. So no page fault occurs. Hit. It's called a hit. So no change will be done because 4 is already in main memory. Next 2. Again 2 is already in the main memory. Okay. So I will replace this one. Erase this one. So again, see 2 is already available in the main memory. So again it's a hit. No change. So 4, 1 and 2. Again 4. So 4 is also available. So there is no page fault. Okay. There is no page fault. It's again hit. Again 1. 1 is already in main memory. So again there is no page fault. It is a hit. Again the last one 3. So 3 is not available in the main memory. So which page should be replaced among 4, 1 and 2? So 4 starts from here, 1 starts from here and 2 starts from here. So among these 4, 1 and 2, 2 is the first to be loaded in the main memory. So 2 will be replaced with the required page. So what is the required page? The last one 3. 4, 1 and 3. So here it is not available, so it is a page fault. So this is how we will load the required pages from the page reference string to the main memory. So in this process we have to find out the number of page faults, number of hits and the hit ratio. So now we can see, so number of page faults is equal to 1, 2, 3, 4, 5, 6. 6 page faults. And number of hits 1, 2, 3, 4, 5 and 6. Right? And a hit ratio. The hit ratio is equal to number of hits by total pages in reference string. So that is equal to number of hits is 6 divided by reference strings 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So 6 by 12, that is 1 by 2. The hit ratio is 1 by 2. Right? Hope you understood this one. So we have to find the number of page faults, number of hits and the hit ratios. So one thing, again I am repeating, if the required page is not available in the main memory, then this page fault will be occurred. Once the page fault occurs, the next step is we have to load the required page into the main memory. In that process, we have to check whether the memory is available or not. If it is not available, we have to apply the swap out and swap in. So that means remove the page, one page from the main memory and load the required page into the main memory. So in this algorithm, we will select the first page which is to be loaded in the main memory, that will be replaced with the required page. Right? So hope you understood this Fifo page replacement algorithm. So in the previous session we have seen the first in first out page replacement algorithm. So here we'll go with the another session on Fifo, that is Belady's anomaly problem. So first of all, let us explain what is this Belady's anomaly. So in the previous example, we have taken the same reference string and we have applied the Fifo replacement algorithm, page replacement algorithm. So we have taken the frames is 3, so that we got the page faults as 6. Now, if we increase the frames, that means if the main memory contains more frames, so automatically the page faults should be decreased, right? So in this Fifo, this may not happen for all the reference strings. So for some reference strings, even though you increase the frames, the number of frames, the page faults may also be increased. So such type of phenomena is called Belady's anomaly problem, right? So let us check with the reference strings. So this is the reference strings we have solved in the previous session. So with the 3 frames, so that we got the 6 page faults, right? So once go through the video of Fifo and then you will get clarification. So I will post the link of the Fifo page replacement algorithm in the description, so you go through so that you can understand. Now here we will solve this with the number of frames 4, so that we should get the less number of page faults. That means we have to get less than 6 page faults because we are increasing the number of frames, right? See, so frames F1, F2, F3 and F4. See, right? So you can observe first, the first one. So page 1 is occupying the frame 1. So it is a page fault because 1 is not available in the main memory. So we will call it as a page fault. Second reference, the page 3 should be inserted and that page is not available here. So again there is a page fault and again I am including this one. Coming to the third one, 1, 3, and again 2 is not available. Again there is a page fault, 2. Coming to the fourth one, so 1, 3, 2, 4 is not available. So 4 is placed in the fourth frame. Again page fault. Now see, you can observe here. Now 4 frames are filled. 4 frames are filled. So here 2. Next one is 2. 2 is already available. So hit. There is no page fault. Okay. So no page replacement should be done here. Next 3. So coming to the 3. 3 is already available in the main memory. So there is no page fault. Again there is a hit. Coming to the next one. See 1. 1 is already available. So again there is no page replacement. Again it is a hit. Again next 4. 4 is available. Again hit. 2. 2 is available. So there is no page fault. So it is a hit. Okay. Again 4. So 4 is also available, no page fault. Again hit. Next 1. So 1 is also available, it is a hit. 3, and again 3 is also available here. So again hit. So after completing all the reference string, you can observe there are only 4 page faults. So we have applied the same reference string using the Fifo algorithm with the 3 frames. We got a 6 page faults, and this is also a Fifo. So we just followed the Fifo. Okay, we just followed the Fifo, but here we got only 4 page faults. So reduced. So if you increase number of frames, automatically the page faults will be reduced. But here in this, this is a problem we will get in Fifo. That is, it may not reduce the page faults with the increase of frames. So in some reference strings, even though we are increasing the frames, the page faults may also be increased. So let us see such type of example so your doubts will be clarified. Right? Right. So in this case, in the previous session we have solved with the same reference string, but the page faults have been decreased because increase of frames. See. Now we will go with the next one. Okay. So we will take one more reference string and we will apply the Fifo with a less number of frames, and we will increase the frames and we will observe how much we will get. Okay. See. Okay, first we will observe with the three frames. Okay, so the reference string right. Let it be this is the reference string. So we'll get first we will see with the 3. Okay, now we'll observe here. See, so 1 is placed here, it's a page fault because 1 is not available. And coming to the second one, so 2 is also not available, again it's a page fault. So 1 and 2, and then 3, again it's a page fault. So 1, 2, 3, again now 4 is also not available in the string, in the memory. So we have to replace, again it's a page fault, we have to replace. Which one we have to replace? The first in, first out. So first page we are allocating in the frame that should be removed. So here 1 is the first page among these 3. So we are replacing 1 with 4. Next, see, again 1. So 1 is not available here. So again we have to apply the Fifo for replacing the page. So among these 3, 2 is the first string. So 4, 1, 3. It's again page fault. See, again 2. 2 is also not available, again it's a page fault. So which should be replaced? Among these 3 is the first. So 4, 1 and 2. Again we can observe, again it is a page fault because 5 is not available. We have to replace. So among these 3, 4 is the first one. So 4 will be replaced with 5. So then again apply here 1 is already available. So it is a hit, not a page fault. So nothing should be replaced because 1 is already in main memory. Next 2 is also available in the main memory. So it is not a page fault, it is a hit. And we need not replace any page. So again next 3. So 3 is not available. So we have to replace the page. So again it is a page fault. Which page we have to replace? So 5, 1, 2. Among these 3, 1 is the first one. So 5, 3 and 2. Next 4 is not available in here. So again it is a page fault. Among 5, 3, 2. So 2 is the first one. So 2 is replaced with 4. And again last one, that is a 5, which is already available. So we need not go for the replacement. So it is a hit. So after completion of this reference string, we can count the page faults 1, 2, 3, 4, 5, 6, 7 and 8, 9. So there are 9 page faults. For frames is equal to 3 frames. So if you go with the frames 4, see, if you observe here, the same thing we are applying with frames 4. So, according to our assumption, if you increase the number of frames, automatically the page fault should be decreased. So, let us check. So, first one, take the first one. So, again it is a page fault because it is not available. 1. Coming to the second string. Second one, 2 is not available. So, again it's a page fault. We have to load it in the main memory. And the third is also not available. Again it's a page fault. See, fourth one, 4 is also not available. Again it's a page fault. 1 is already there. So it is a hit. So we need not change the page. 2 is also not available in the memory. So it is again hit. 5. So 5 is not available. We have to replace 1 with 5. It's a page fault. 1 is not available here. So we have to replace this one 2 because among all these 3, 2 is the last one. So 2 will be replaced with the required page 1. So 5, 1, 3, 4. Again, the next one is 2. 2 is not available. So among these 3 is the first one. So 2 is replaced with the 3. Sorry, the page 3 is swapped out and 2 will be swapping in. So again, this is a page false. Okay. Next, 3 is not available. So among 5, 1, 2, 4 is the first one. So we have to replace the 4 with required within 3. That is a page fault. Again, coming to the 4 is not available. So among 5, 1, 2, 3. So which one comes first? Fifth one. So 4, 1, 2, 3. So it is a page fault. And again 5 is not available here. It is also a page fault. Okay. So which we have to replace? So 4 starts here, 1 starts here, 2 starts here, and 3 starts here. So 1 is the first one. So we have to replace 1 with page 5. 4, 2, and 3. Right? So this is how we can solve with the 4 frames. Now if you count this page faults, see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the page faults are 10. So even though you increase the number of frames, there is no chance of, there might be a chance of increasing the page faults. Okay. Right? So in some cases, not in all cases, in some reference strings, this will happen. And this phenomena is called Belady's anomaly. Right? So hope you understood. So increasing the number of frames may not decrease the page faults, particularly in Fifo replacement algorithm, page replacement algorithm. In the previous session, we have covered the Fifo page replacement algorithm and then Belady's anomaly in Fifo. In this session, we'll go with another page replacement algorithm called LRU. So LRU stands for least recently used. So while loading the required page from the secondary memory to the main memory, so we'll find whether the memory is full with the pages or not. So if the memory is full, then we have to replace the existing page in the main memory with the required page. So that will be happen. That means here the question is which page should be replaced. So that depends upon these algorithms. So in this algorithm, whatever the page least recently used, that page will be replaced with the required page. So let us consider this reference string. So these are the pages. Okay, these are the pages. So we will consider this reference string and we will solve by using this least recently used. Here, the number of frames is equal to 3. Now we have to find the page faults and hits. How many number of hits? Now we will see. So how it can be solved. So first, page number 1. So all 3 frames are available. So there is a page fault because the required page is not available in frames. So now we can load that in the main memory. Next, coming to the 3. 3 is also not available in the main memory. Okay, you can observe only 1 is there, 2 empties. So 3 is not available in these 3 frames. So again, there is a page fault. So I will load this 3 in frame 2. Now 2, reference string 2. So 2 is not available in the frames. So again there is a page fault. So we have to load this page 2 into the main memory. So I will load this page 2 in frame 3. Now all these 3 frames are full. Now next reference string is page 4. The required page is 4, and if you check whether 4 is available, here the 4 is not available in the main memory. So again there is a page fault. So what we have to do? Again we have to replace one page among all these 3 with this 4. So if you observe here, so we have to replace the least recently used. For that purpose, just follow towards the left side and find out the least recently used. So the required page is 4. So next to this 4, the leftmost one is 2. 2 is recently used, most recently used, because in the previous session itself, in this previous thing itself, we have loaded 2 because so this 2 is a most recently used. Again 3 is also used. 1, so 1 is the least recently used. Among these 2, 3, 1, so if you give the priority, 2 is in first second, 3 is in second, 1 is in third second. So 1 is the least recently used among these 3. So I have to replace 1. So replace 1 with 4, 3, 2. Hope you understood. So travel from the required page towards the leftmost and find out which page is the least recently used. Right. coming to this 2. So 2 is already available in frame, main memory. So it is hit. So no change will be done. So no replacement will be done. So 3 is also available in here. So again it is a hit. So no change will be done, no replacement will be done. Now 1. So 1 is not available in the main memory. So we have to find out the least recently used page. So travel towards the left. So 3 is the most recently used. 2, the next recently used. 4. So among these 3, 4 is the least recently used. Right? Replace 4 with 1. So it is a page fault because it is not available. Right? Next 4. So 4 is also not available in the main memory. So again find out the least recently used. Right? So because of here the number of frames 3, we can travel only 3 sessions. I mean 3 reference strings. So 4, 1 is the most recently used, 3 is the next recently used, and 2 is the least recently used. So 1, 3, 2, among these 3, 2 is the least recently used. So 2 will be replaced with a 4. Okay, then 2 is again not there. Okay, again it's a page fault. So we have to replace one page. Again travel towards the 3 reference strings, 4, 1 and 3. 4 is the most recently used, 3 is the least recently used. Replace 3 with 2. Right? So again 4 is available. So it is a hit, not a page fault. So nothing will be happen. So no page will be replaced. Again 1. Again it is available in the main memory. So no change. So no replacement. So it is a hit. Again 3 is not available. It's a page fault. So again what we have to do? We have to travel towards its leftmost. So 1 is most recently used. 4 is second thing. The 2 is the least recently used. So replace 2 with 3. 1 and 4. Right? So hope you understood this least recently used algorithm. So if you count this one, 1, 2, 3, 4, 5, 6, 7 and 8. So 8 page faults are there and 1, 2, 3, 4. 4 hits are there. Okay. So hope you understood this one. So all these one are reference string. Okay. All this one is a reference string. Right? So don't get confused here. So this is completely reference string. And this is the main memory where we are loading the pages. Okay. Right? Don't get confused. So here we have to find the least recently used page and that should be replaced with the required page. So for that we will travel from towards the leftmost 3 frames. 3 frames means here we are using 3, so we will travel 3 frames towards the left side from the required page. The previous session we have seen the LRU page replacement algorithm, that is the least recently used page replacement algorithm. So in that, in order to load the required page from the secondary memory to the main memory, so we have to find the free space in the memory. So if all the memory frames are full, so we have to replace one page from the main memory with the required page. Right. So which page should be replaced depends upon the page replacement algorithms. So in that we have already covered the Fifo and LRU. And now in today's session we will see the another page replacement algorithm called optimal page replacement algorithm. So in this situation, so we have to replace the page which is not be used for a long duration in future. Right. So hope you understood. So we have to replace a page such that should not be used a long time in future. So coming to the least recently used algorithm, we have seen if we want to load this page, page 2, so we have to select the page which is least recently used. For that we have traveled from the required page towards the left side. And in this we have to load the page such that, we have to replace the page such that it should not be used long in future. So we have to travel the same thing in right direction, right? So we'll solve a problem so that if you are having any doubts, so that those doubts will be clarified, right? So here also I am taking the same reference string, so which we have solved in both the Fifo and LRU. The same reference string I have taken, and I have taken the 3 frames. The number of frames are 3. So now we have to find out the page faults and number of hits. And page fault is if the required page is not available in the main memory, that is called a page fault. And if the required page is available in the main memory, it is a hit. Right. Now we'll start the solving. So first 1. So all the 3 frames are empty, so we can load the page 1 in the main memory. So I will load here. So that means here it's a page fault. Okay. So here it is a page fault. Now next reference string is 3. So again 2 frames are free. So again I am loading it here. So again it is a page fault because 3 is not available in main memory. And 2 is also not available in the main memory. So again it is a page fault. And I will load this 2 in frame 3. Now 4. Page 4 is not available in this main memory. So there is a page fault. And there is no empty frame available in the main memory. So we have to swap in and swap out. So we have to first swap out the one page from the main memory, and we have to swap in the required page from the main memory to, load from the secondary memory to main memory. So for this, we have to select the page which is not going to be used for a long duration in future among these 3, 1, 3 and 2. For that, the required page is 4. So travel in this way. So 2. So immediately we require the 2. 3. Immediately we require the 3. 1. So the third position is 1. So among these three, 1 will be having a lot of time to load. So replace 1 with 4. 4, 3 and 2. Hope you understood, right? So among these 3, 1, 3, 2, 2 is the immediate reference page, immediate page in the reference string, and the 3 is the immediate page after the 2 and 1. So among these 3, 1 is have to wait until it loads the 2 pages. So 1 will be replaced with 4. Now again 2 is available in main memory. So it is a hit, no page fault. So we need not change any page. We need not swap in and swap out the pages. Right. Again 3 is also available in the main memory. So again it's a hit, it's not a fault. So again no need of replacing any one of the page. Now 1. So 1 is not available in the main memory. So it is a page fault. Now we have to replace one among these 3 pages. So for that we have to select the page which is not going to be used for long time. See, travel towards its right. So 4, 3, 2. So 4 immediately we require, 2 immediately we require, 4 and 1. So 1 here not there, right? 3. So 3 is the 3. In order to load this page 3 into the main memory, it requires around 4 iterations, right? So after loading the 4 pages, the next one is a 3. So 3 is waiting time of a 3 is more, right? So the 3 will be replaced with 1, 2 and 4. So hope you understood, right? So among these things, 4, 3, 2, 3 is not being used for a long time. Okay. Next, coming to the 4. 4 is already available, so it is a hit. So we did not change anything. And the 2, till 2 is also available here. So again hit. So we need not change here. And a 4 is already available, so need not change. Again it's a hit. 1 is already having, so again it is a hit. and 3 is not there, 3 is not there, and 3 is a last string, last page. So after 3 there are no other pages, so we can replace any one of the page from the main memory. So I will replace one or any page. Okay, so I will replace the 4. Okay, right. So if you observe here, see, so these are the hits and page faults occurred while loading the page reference string into the main memory, applying the optimal page replacement algorithm. So only one thing, the page should be the replaced page. I mean the page which is not being used for a long duration in future, that should be replaced with the required page. For that we have to travel from the required page towards the rightmost direction. Right? So this is how we can implement this optimal page replacement algorithm. So here the number of page faults 1, 2, 3, 4, 5 and 6. 6 page faults are there, and number of hits 1, 2, 3, 4, 5 and 6. 6 hits are there.